Good morning, all. Welcome to another tutorial from We Are Learning. Today, we will be seeing about clustering. Clustering is a concept in data mining where we would like to segment the data that we have into different clusters. Thereby, we can apply more analysis or maybe doing a prediction. Clustering can be broadly classified into supervised and unsupervised. So, unsupervised clustering means there is no dependent variable means or independent variable. You take the entire data set and try to segment them into a smaller pieces so that you can have a close look of the data and maybe take a business decision accordingly. In clustering, if we go on the unsupervised part, a broadly classified structure is hierarchical clustering and partition clustering. In hierarchical clustering, again, you have agglomerative and divisive. Agglomerative is more of a bottom to up approach, whereas divisive is a top to bottom approach. And partitioning is more about it will represent a cluster with means into a concept. So we can say k means as one of the partitioning concept. We will concentrate on hierarchical clustering in this tutorial. So what is hierarchical clustering and how agglomerative methodology can be used to segment a data? So in a hierarchical cluster, what it does is, first of all, if you have an n items in the data set, it considers all n items as a cluster. So you have 100 items in the data set. It first considers to be 100 clusters. And then it will find the most closest or most similar pair of clusters and merge them into a single cluster, so that now you have a fewer cluster. And then the process continues. All the items are finally clustered into a single large structure as one cluster of the n items in the dataset. So this is what hierarchical cluster does. And agglomerative is the bottom to top approach, and we can use a dendrogram which try to give a visualization of the clusters that we have, and it helps us to understand which number of clusters is optimal for us. That's how hierarchical clustering works, and there are advantages and there are disadvantages with hierarchical clustering. It is very simple to use hierarchical clustering. It works fantastically in a small data set, and if you visualize it, it looks very nice to easily identify the clusters that we have. But the disadvantage would be it is not randomized. It does not randomize the data that is provided given in the data set, and it is not fast. So these two are disadvantages. But to do hierarchical clustering, I would mention that we do not require a domain knowledge. We just have a data set, and it is okay enough that it is not so complex or so big that you can apply a hierarchical clustering and try to see a segmentation, what has happened. Okay. Here, I have taken a sample bank marketing data set, and we will try to apply the hierarchical clustering. It's not more about the data that we are trying to understand here. We will try to understand more about the concept of hierarchical clustering. Okay. So first, we will import all the required packages. You would require pandas, matplotlib, seaborn, and we will also see, given the data set, right, do you really need to scale the data? Okay, so let's see what are the first five items. So if you give df.head, it defaults you with the first five line items. It starts with 0. So these are the five top line items that you have. You can also see the bottom five. So you have till 210. So that's why it ends in 209. Okay, so now I know these are the columns available in my data set, right? And then you can try to see what are the data types that you have. You may have objects, you may have integers, floats, because some columns may be categorical that you have. You should really understand before applying the clustering methodology what kind of data we have. Fortunately, it's all floats that we have, numbers, that's me. And then we will see, do we really have any null values? uh, if yes, should we ignore that? Should we assign some default values, a median, mode? That comes to the next level. I have taken a simple data set, so it is null, and you can see there is no null in this data set, so it's all 0. We'll just try to see the shape. So we have seen that it has 210 rows and 7 columns. And now this comes as an important section, and I'll explain you why this is important. But if you put a describe, you can see what are the counts. You have 210, so all are 210. So there is no missing values that you have, and you see the means, standard deviation, minimum, and what are the quartiles that is available. Yeah. And then we can also see the description in a histogram to see how it is spread. You can see it is not normally distributed and it is skewed. One more important thing that we have to understand in clustering is that you don't require a normal distribution, right? And I would suggest we do not consider variance, just to ensure that we are not considering the normal distribution, because if you see your data to be normal distributed or assume it to be a normal distributed, I think we cannot get into the smaller segments of the clusters, right? You will see in an overall way. You cannot go to the bottom of it. So it's nice and it's better. We don't consider the variance in this clustering methodology. Okay. So I have seen this. Now let's see, should I really do a scaling? Means my data, if you see, these can be in different scaling units. One can be in thousands, one can be in um, you know uh, ranges of 1 to 10, but not in ranges of thousands or hundreds. There may be percentage in between. So these are of different unit in scales. Now if you want to cluster them, you would not be able to do a justified methodology unless and until you scale them, and that's why scaling is very important. um, what is the other way to quickly understand why should I scale? If you see here, the mean, right, it is not the same across. You can see the means are different, the standard deviations are different. So you cannot consider these two columns, spending and advance, or, or spending and probability of full payment, or same kind of columns, and try to cluster them. This will fail, and that's why we should do a scaling. And the most common scaling that we use is z-score. Yes, you can import it from the scipy, right? And I am now taking the data set into df underscore scaled rather than df, so that now using the scaled data, I'm going to go ahead. Now you can see all the data are scaled in all the columns, right? For all the rows, 210 rows that I have, right? Now, what is the quickest way to see I have done the scaling? So how am I going to see the difference? Now you see the mean is 0, almost 0. See, mine e to the power of minus, so it's almost 0. You see the standard deviation, it is 1. That means now these columns are eligible enough to be considered as similar columns to ensure that we start doing a cluster between them. Yes, and you can also try to see a box plot, and you can see that the means are almost zeros, right? The standard deviation is in the 1, right? And not much outliers that you have. Looks decent enough. So now that the data is ready, let's go and apply the hierarchical cluster. Okay, you take this scipy cluster hierarchy and you import the dendrogram and the linkage, right? This time we are using the word linkage. Okay, and the matrix is Euclidean, means this is a distance based formula to understand how the clusters are closer to each one and how similar to each one, and then it start forming the clusters. As I explained before, if you have 100 data, it will take 100 as the first cluster, then make it into 90, 80, unless and until it ends as one full cluster. That's what it is going to do. These are few PLT labels that I have given, and then I would like to give some sizes, thresholds. Threshold is something I will show you once the data comes out in the dendrogram. Yeah. So system has processed the data, right? And if you could see, it started with a single clusters everywhere at the bottom, right? And then it will try to make two clusters, right? This becomes three as separate, and then it is trying to cluster this. So these are very close or similar. Then those are becoming a one more cluster and a bigger cluster unless and until you find one full cluster. So under this cluster, all the data sets are available. This is what hierarchical clustering does, and this is the visualization you see in the dendrogram. This can be more complex as a visualization. If you see there are more data, so you can always restrict it to some numbers. So I have given number as 10 over here, and so that I see a less truncated value. Okay, so I have truncated it, correct. And I'm trying to see what is the last p values, and I want to see only 10 clusters. So here's where you see that. Okay, and rest all remains the same formula that you have put on the top, and I want the axis line to be on the 20, and it should be black so that it can clearly show me how many clusters I would like to see. So you can see when this axis line cuts the dendrogram, it cuts three lines, 1, 2, and 3. That means optimal is 3 clusters that I can take using this hierarchical clustering methodology. And we can now go and narrow down to 3 clusters in the overall data set, right? And then you can bring this into an array using an agglomerative clustering. This is what I told you, like this is the bottom to top approach, right? So I know it's 3 clusters, so I've given clusters as 3 for them. And then I give the distance formula is Euclidean, right? The linkage formula is Ward, okay? And I'm trying to fit this, and it has converted the entire data into an array. So you can see 0, 1, 2. So the first element is in first cluster, the second element is in 0 cluster, the third element in first, the fourth element is in second cluster. So it converted all the data into 3 clusters, right? Now I want to just group all these things using the group by option, right? And see the mean of it, of all the rows, all the columns that we have, and then try to see in a pivoted way. So here you see cluster 0, 1, 2, and you see all the 7 columns that I had, correct? And it also gives how many cluster counts that you have, right? If you count, that will become 210 for us. And you can see the mean value. If I take spending as one column, it has considered 11.87 to be of a mean of one cluster, and how many data that was available which has a mean of around 18.37 has been considered as one cluster, and 14.19 as another cluster. So these are the 3 clusters now I got from the data set. It's easy to see the segmentation, yeah. And now you may apply a different business recommendation, understanding, okay, this is what probability of full payment says, or maximum spent in single shopping says. So you may put a different business knowledge to it and try to give some kind of an understanding to business how they can improve it. Or after that you have done your segmentation clustering, you may apply different other methodologies depending upon the business problem that you have got. But this is a simple way to do a clustering using hierarchical methodology. In another tutorial, we will see k-means as well. I hope this has been of useful to you. Please apply and try to do by yourself as well. Clustering, it's a fantastic methodology to do the first level of understanding. Once you have cleaned the data, this is the best way to see what is there in the data and what best we can try to derive out of the data. Try by yourself, and I hope this will be of helpful to you. Thank you.